Okay, because colas tend to replace healthier beverages, yeah, I know that, contains caffeine and phosphoric acid. Okay, consumption of cola associated with lower bone mineral density. So it's all this blah, blah, blah stuff at the beginning. What I want to know is what's X and what's Y. Well, we want to use cola to predict bone density. Cola is the explanatory or X variable. So we want cola to predict bone density. So let's put this in. Full data set into StatCrunch. Each time I close my StatCrunch window, it pops up on my other screen. I have to switch mice and bring it back over. Okay, so I'll close this data table for now. The least squares regression line. So, stat, regression, simple linear. So which is the explanatory variable? Which is the X? Is it soda or is it bone? Yes, it's the cola, because we're using the cola to predict bone mineral density. Compute. And here's the equation, which StatCrunch has given us to an unbelievably large number of decimals. Okay, so the slope, that's the number in front of the variable. So the slope is minus 0.003. So we have to look for the one that has minus 0.003 in front of the X. So that could be A. Actually, that's the only one. The slope has a minus 0.003, and then the other number, the intercept, is 0.88 something. So that matches answer A. The number in front of the slope is minus 0.003, and the intercept, the other number, is 8866. Okay, interpret the slope. The slope is negative. So for each increase in X, which means one additional cola, the slope is negative. That means the density will decrease by 0.030. That's what the slope means. X goes up by 1, Y goes down by minus 0.003. Okay, that's the second part. Let's see. Choose the correct answer for the intercept. Okay, where's my pen? So what was the equation of the line? The equation of the line was y equals minus 0.003 plus 0.80, x plus 8866. So the slope is x goes up by 1. It's an arrow going upwards. Y will go down by 0.003. The intercept, that's the value of y when x equals 0. You can see in this equation, when x equals 0, that term is 0. So what we need to do is to figure out what x equals 0 means. X is the number of colas. X equals 0 means this woman drank no colas, or drank 0 colas. So does that make sense? Yes, there are people who drink no colas. So interpret the intercept. It is appropriate for a woman who does not drink cola. the bone mineral density will be 8866. That's choice D. Okay, so for a woman who doesn't drink cola, the value is the intercept. Okay, so let's continue. A woman drinks 4 per week. The predicted value is what? Well, the equation was y equals minus 003 x plus 8866. It says, what's the value when x equals 4? Predicted for 4 colas per week. Well, let me multiply that. I'm going to do this by hand. Right, 3 times 4 is 12. This is minus, so I subtract. 6 of 4, 7, 8. So all I did is I put in 4 for x, so I got that y equals minus 012 plus 8866, and I just did the subtraction, 8746. So this is a case where you don't overthink this. Here's the equation with y and x. The problem asks, what's y when x equals 4? Just stick in x equals 4. So it's 8746. So let me put in 8746. Whoops, there's an 8 there. Nope, there's an 8 there. 8746. Exactly, Moretta. Put in 4 for the x. So this woman actually was at 87.3. So if 87.3 is where she is at, is that above or below the average? It's below. 87.3 is less than 87.4. So this woman is below average. Okay, in other words, she's going to have a negative residual. Part F, the last part. This one was tricky. I often miss it the first time I go through it because I don't read it carefully enough. Can you use this model for a woman who consumes 2 per day? Well, the tricky part is the data is for colas per week. So this is 2 per day. 2 per day is 14 per week. So let's take a look at the data again. Full data set. I'm going to do a scatter plot just to see. Graph, scatter plot. Colas is X, bone density is Y. So here's the scatter plot. So the question is, this woman drinks 2 per day, so she drinks 14 per week. So does it make sense to predict someplace out here for 14? Well, we have no data there. We have no reason to believe that it's the same trend that's continuing past 6 and 8 and 10 and 12. Whenever we are trying to do something beyond the range of the data, it really is very tricky and dubious. In this case, we have no reason to believe that the pattern continues past 8, and so we should not use the model. The point is beyond the analysis range, is outside the analysis range. Okay, so that was problem 10.